Hello, everybody, and welcome to our webinar, Ultrasonic Sensors MD Portfolio. Before starting, let me briefly introduce myself. I'm Giovanni Principe, the Product Manager for Ultrasonic and Capacitive Sensors in MD Microdetectors. And today, I'm gonna lead you during these very intensive, these tough lectures, but I hope also interesting for all of us. Luckily, I'm not alone here, but a colleague of mine, Giovanni Di Lorenzo, who is our product manager for inductive and applicative sensors and for accessories in MD Microdetectors, is going to support me collecting your questions and trying to answer them. So please, if you have any doubts, any curiosities, if something is not so clear, do not hesitate to write down your questions, addressing them to our Q&A profile in the Zoom chat. And Giovanni will be very happy to help you. Right, Giovanni?
Yes, correct.
Okay, thank you, Joe. Now, I think that we are ready to start. So let's go. What we are going to talk about today during this lecture. First of all, we start with the discovery of all the hidden secrets of the ultrasonic technology. Then we are gonna translate this know-how into practical applications, discovering all of those, let's say, interesting cases, practical cases, where we have solved some applications, some problems. Then we start with, let's say, with the exploration of our portfolio, our ultrasonic sensors portfolio, with the M18 sensors, UK1 and UK6 series, followed by the M30, the UT series, and then going to the hybrid sensors with the UK1 series. At this point, I want to underline the fact that we already talked about the UK1 series during our first webinar, UK1 series applications and IO-link communication. So if you have lost this important date, I invite you to go online on our website and see this video, which is already available in the webinar sections. And also it's available on our YouTube channel. So please visit our website and our YouTube channel and subscribe to get in touch with our news. Then we are following with the cubic ultrasonic sensors of the series UH. Then ultrasonic forks, FC8. And finally, we are going to conclude this lecture with the practical part. So how to adjust a sensor. In particular, we are talking about the teach-in mode used in UK1 and the UT series, and remote mode used in UK6. Let's go with the discovery of all the secrets of this technology. The first question we are going to answer today is, how does an ultrasonic sensor work? Basically, an ultrasonic sensor is based on a transducer with a piezoelectric ceramic disc acting as an active element. This disc, through the action of high frequency voltage, starts vibrating and producing some sound waves, some ultrasonic waves. These pulses are transmitted through the air and they hit against a target surface. This target surface is represented by the object that we want to detect. Then the same waves come back always through the air towards the active head, towards the transducer itself, to be read. Here, the sensor translates these vibrations into electrical signals. As a consequence, the sensor is able to compute the distance of the detected object on the basis both of the speed of sound, because as you know, the sound has a characteristic speed when transmitted through the air, and on the basis of the time lag between the, let's say, the emission, the instant of the emission of the wave itself, and instant of the reception. What about the blind zone? The blind zone is related to the fact that the emitter and the receiver live together into the same active element. It means that the piezoelectric disc is not able to stop when passing, to immediately stops when passing from the emission to the receiving mode. But it continues vibrating for, let's say, a certain time lapse. During this time lapse, it is impossible for the sensor to catch any kind of echoes. It is physically translated into a minimum distance within which it is not possible to catch anything. So please, when designing your application, take into account this fact. So take into account the fact that it is not possible to have a detection, a stable and affordable detection of an object within this blind zone. Of course, the blind zone is in function of the maximum distance. So the higher the sensing distance, the higher also the blind zone. What about the target surface? First of all, we have to say that with a direct diffusion mode sensor, the surface should be almost perpendicular to the acoustic cone axis, because just only in this way it is possible to have the maximum in terms of reflection, so to have the maximum effectiveness in terms of the object detection. Because otherwise, if there are some slopes of the surface with respect to this perpendicular position, the acoustic cone will be reflected away and not towards the transducer. Another important characteristic of the target surface is the, let's say, about its nature. It should be almost flat and regular, because otherwise some, let's say, sound degradation would occur. Okay, now target material. The ultrasonic technology is able to detect any kind of materials, metal, plastic, wood, glass, and it is not afraid of the surface color. Like, for instance, in the case of photoelectric sensors, because in this case, you know, the behavior of a photocell is highly depends on the color, because, you know, a white object can be seen by the sensor at a high distance. On the other side, a black surface can be seen at a reduced distance, because black as a color has a high, let's say, light, high energy absorbance. And then an ultrasonic sensor is not afraid of the transparency. So if you have glass, if you have other kind of transparent objects, you can use an ultrasonic sensor. Pay attention to the sound absorbing materials. like, for instance, isolation materials, textiles, because they act like a spoon with the water. They create a sound absorbance, and they do not make it possible to reflect sound back to the transducer itself. So if you have a sound absorbing material, your effectiveness with your sensor is reduced. So how to solve problems with this kind of applications? Simply by using most powerful sensors with respect to the strictly required power. For instance, if your application requires just, let's say, 200 millimeters in terms of sensing distance, you can use an ultrasonic sensor able to read till 400 millimeters. Because in this case, you know that the power is higher, so you have a higher probability to get back the energy, to get back the acoustic waves. Here you can observe in this funny picture some potatoes. Why? Because also potatoes create a sound absorbing surface, and we already have some applications with plants working with potatoes. In these cases, you can see that potatoes show different profiles. So the surface is quite irregular. And then that there are a lot of empty spaces among different potatoes. So what? This produces a great, let's say, sound degradation. In order to avoid that, we installed very powerful sensors, very powerful ultrasonic sensors, in order to catch the presence of the potatoes themselves. Now, with Giovanni, we want to show you how different is the behavior of a sensor when skipping from, let's say, an ideal target, an ideal metal target, to a sound absorbing one. You can observe now there is a new UK1 sensor, and we are using a metal flat target. Giovanni is moving it away, and you can observe that the green LED is still active. The green LED, let's say, shows that the sensor is catching back the echoes coming from a surface. And in this case, you can observe that the regularity of the surface can grant high distances. On the other side, if we change the nature of the target surface, skipping to a sound absorbing surface, you can see that we won't go so far, because the LED, the green LED, disappears very soon. Why? Because, as I explained before, this sound absorbing surface acts like a spoon with the water. It creates an absorbance of the sound. So a further recommendation when designing your application, please keep in mind this important stuff. Okay. We can continue with the environmental factors, and we can see how, let's say, the environment can affect the behavior of an ultrasonic sensor. Why? Because I've said that the ultrasonic waves are transmitted through the air, and the factors, let's say, the characteristics of the air are so important in the transmission of the sound itself. For instance, the pressure. Our ultrasonic sensors are designed to work with the standard atmospheric pressure. It means a pressure of 1 atmosphere or 1 bar. Otherwise, if we change the pressure higher or lower, we will have some nonlinear behavior of the speed of sound. On the other side, the temperature, the air temperature. In this case, since as you know, the speed of sound has a linear behavior with respect to the air temperature, we have installed within each kind of model of ultrasonic sensors, we have installed, let's say, a mechanism of temperature compensation. It means that the sensor is always able to correctly translate, to correctly understand which is the right speed of sound. Here you can observe some sound absorbing materials like powders, like snow, and we already seen what does it mean in terms of effectiveness. And let's spend some words about the wind. If you have wind, you would have some deviations in terms of acoustic cone. In fact, the acoustic cone will not go directly towards the active head, but it will go away. Okay, now let's talk about a little bit of retroreflective sensors, because till now we faced this discussion about the diffusion mode. The diffusion model, which is the let's say the most used in a lot of applications, but you can use also this interesting model, which is the retroreflective sensors. How does it work? It works with the presence of a background, with the presence of a wall. So the principle is quite easy. You are reflecting continuously these ultrasonic waves against the background. When any kind of object passes through the active element and the wall, it interrupts this flow and make it possible to detect the presence of the object itself. As a consequence, this kind of solution makes it possible to detect any kind of objects, no matter their shape, no matter the regularity of their surface, and no matter the material. In fact, also sound absorbing surfaces can be detected with this kind of solution. Furthermore, of course, in this case, we do not talk about blind zone, but we talk about minimum distance, background distance, so minimum distance where we can set this background. Okay, now something interesting that we have on some models, for instance, on our UK1 and UT series, which are the, let's say, the synchronization and multiplex functions. They made the sensors able to work together, one beside to the other. In particular, the synchronization function makes it possible to sensors up to 10 to be connected together and work one beside to the other when referring to the same surface, to surfaces to the same distance, because in this way the sensor emit the acoustic waves at the same time, and you are sure that each sensor is receiving just the waves that it emitted previously. And on the other side, it does not receive waves coming from other acoustic cones, so no interferences are created. When you use more sensors simultaneously, but with reference to different surfaces, to different distances, you can use the multiplex function. This multiplex function makes you possible to use up to 4 sensors simultaneously. But in this case, since the emission reception are split into different time lapse, as you can observe here in the picture, the total system response time is, let's say, increased. It's the reason why there is this maximum of 4 sensors, because of course we have to solve practical issues when having more sensors working together, but we have also to grant an high response, an high responsiveness of the sensor itself. Okay, let's go now on the, I think, most difficult part of this today lecture, the response curve. What does it represent, this response curve? It approximately represents the, let's say, the shape of our acoustic cone. And here you can observe it in this graph that you can read on our catalog, on our data sheets. And you always read more than one profile. These profiles refer to different targets that we use. The first one, so the black one, the wider, refers to a standard target, rectangular target of 100 times 100 millimeters, metal flat target. And as you can observe by this diagram, we have a very wide, let's say, acoustic beam. On the other side, if we use another kind of target, in this case a round object of a diameter equal to 25 millimeters, another acoustic cone is drawn, and it is this one, the blue one. What does it mean? It means that a precise description of the shape of the acoustic cone is not possible, because as you use a different kind of target, the width and also the length of this cone will change. Let's say if we used let's say another kind of target, for instance 500 times 500 millimeters, probably this acoustic cone will be let's say of a higher distance. But then another important stuff is related to the to the interpretation, how to read these diagrams. Let's keep in mind that the reference is represented by the medium axis of the target itself. It means that in order to get the right width of the acoustic cone, refer to a specific distance from the active head, you should subtract to the let's say to the width that you read here, the half length of the target itself, both on the upper part and on the lower part of this diagram. Okay, just to conclude this first theoretical part, we want to show you a comparison between these two interesting technologies. On one side, the ultrasonic technology, on the other side, the photoelectric one. First of all, as we've seen, the ultrasonic technology is independent from the target color, the target surface color, and the target transparency. On the other side, a photoelectric sensor is affected by these aspects, by these factors. Furthermore, the ultrasonic sensor has a high immunity to external light. It's the reason why we can use it in the external applications without considering possible light interferences. While a photoelectric sensor is affected by external light. And in fact, we talk about light interference. We have seen that sound absorbing surfaces can create some problem with the ultrasonic sensor in terms of sensing distance reduction. On the other side, there is no influence of this factor on a photoelectric sensor. And what about dust or freezing in the environment? You know that these factors can create, let's say, can obscure the optical part of a photoelectric sensor, while on the other side, there is no influence on the ultrasonic sensor by the presence of these factors. You know, and we have just seen in the previous slide that the beam angle is very high, very wide when talking about the ultrasonic technology, while on the other side, the photoelectric sensors are based on narrow beam, and you can focus on a specific point if you want. Finally, the detection speed. Because you know that the ultrasonic technology is quite slow in terms of switching frequency. Switching frequency of an ultrasonic sensor is about in the order of some tens of hertz, while on the other side, photoelectric sensors are faster in detecting the objects with a medium-high switching frequency of in the order of some hundreds or some thousands of hertz. Let's move now to the applications. In particular, we want to share with you some of the most significant applications that we already solved with our ultrasonic sensors. Let's start with a green application within the agriculture field, when we supported the activities of distribution of water and fertilizers. For instance, in the first case, there was the necessity of detecting the presence of a tree, of a plant, in order to make it more efficient, the distribution of the water. So in order to avoid that water was distributed when these plants were absent. In this case, the ultrasonic sensor is able to detect the presence of a tree and to command, let's say, the starting of the water distribution when and where a tree is detected. On the other side, there was also the necessity of detecting the high from the ground in order to, when distributing fertilizers, in order to avoid crashes, dramatic crashes. Then let's remain always within green field, so with green energy. In particular, we are talking about solar energy production with solar panel. As you know, in order to get the higher level of energy from the sun, it is necessary to always keep clean, very clean, these surfaces. But on the other side, you know that these surfaces are very, very wide. We are talking about square kilometers of this panel. So someone has automatized this kind of activity with this little funny robot here. And we are supporting this robot during its cleaning activity thanks to our ultrasonic sensor, which is able to detect the empty spaces among different panels. Another application, which is a general application we want to show you, is related to levels in tanks. It's a traditional application we have with ultrasonic sensors. In fact, within a tank, you can, on the one side, detect the level of a material, let's say a liquid material, between 2 points, the minimum and the maximum one, and you can do it with any kind of digital output with the 2 working points. On the other side, you probably you want to directly measure the level in analog terms. So through the analog output, it is possible. Here we indicated this series, the M30, just because these sensors can reach very high distances, and so it is possible to install them at the top of very high tanks. At last but not least, in this bottling, let's say, plants, we have solved the application related to the detection of bottles passing on this conveyor thanks to photoelectric sensors, because in this case we have some transparent materials, because we have glass or also plastic bottles. And for instance, a photoelectric sensor will have some issues related to the transparencies, while, as we said before, an ultrasonic sensor is not afraid of the transparency, and it could work very well. In particular, here we can suggest our through beam sensors of the cubic series UH, as we are going to see later on. Let's start now exploring the product portfolio, so exploring the different series of ultrasonic sensors. And we start with the M18 cylindric models, both with the standard body, so UK1 series, and the short body sensors, UK6. The UK1 sensors can be defined as cylindric sensors with M18 thread and standard body. A first way of clustering all the possible models included within this family is to use the sensing distance. As a consequence, we can distinguish among UK1A, UK1C, UK1D, UK1F, which are related respectively to these kind of distances, from 50 to 400 millimeters, from 100 to 900 millimeters, from 150 to 1600 millimeters, from 200 to 2200 millimeters. Another way of clustering these models is based on the output. In fact, we have single digital or analog output models with single digital PNP or NPN, analog with current from 4 to 20 milliamperes, voltage from 0 to 10 volts. And then we have also double digital output or mixed output with digital plus analog. And of course, we have all models with the IO-Link communication. What about the main features of these products? First of all, we have both plastic and metal products with the AC316L body. Then, about with respect to the electrical connections, we have both M12 plug-in models and cable models. And then about the adjustment, we have the teaching button, the comfortable teaching button on board. And then during the practical part of this lecture, we are going to show you how to set a sensor. Then remember that the supply voltage of this sensor is between 10 and 30 volts, and is very useful when talking about mobile applications, while the temperature range goes between -20 degrees and +70 degrees. Then in this series we have also models with 90 degrees emission, radial emission, so it is possible to install them in very limited spaces. Then if you have some flammable or explosive atmospheres, we also have models with ATEX certification. And then finally, for your harsh applications, when you have to cope with some aggressive external materials which can affect the active element of your sensor, we can grant a protective treatment of the transducer itself. At last but not least, as I mentioned before, for this series, we have both the synchronization and the possibility of having models with the multiplex function in order to grant that more sensors can work well together. Let's move now on the UK6 series. The UK6 are cylindric sensors with M18 thread and short body. As you can observe here, the cluster based on the sensing distance has 3 subfamilies: UK6A, UK6C, UK6D, and these distances are lower with respect to the ones we have seen for the UK1. In particular, the UK6A can grant, let's say, a detection between 40 and 300 millimeters, while on the other side, on the other extreme, we have the UK6D able to detect objects between 80 and 1200 millimeters. In this case, we have just single output, digital or analog, and the possibility of having models with IO-Link communication. Also in this case, we have both plastic and metal housing models, and about the electrical connections, both M12 plug-in and cable models, but a difference with respect to the standard body, because in this case we have no teaching button, but we have a remote teaching via cable, and we are going to show you how to adjust a UK6 sensor. Here, just to say that we can use these sensors on mobile application because of the supply voltage between 10 and 30 volts, and we can have the protective treatment of the transducer itself when working in harsh environments. Let's move now on long distance sensors, the M30 UT series. In particular, we can distinguish among UT1B, working from 250 and 3500 millimeters, UT2F working from 350 and 6000 millimeters, UT5L working from 600 and 8000 millimeters. If we consider the output, we can see that we have the similar distinctions with respect to the ones we have seen for the UK1 models. And also looking at the features, we can catch some similarities with respect to the UK1. Here, about the teaching procedure, about the adjustment procedure, we can say that once we have understood the way of, let's say, teach an UK1 sensor, we will be able to adjust also an M30 sensor. Okay, also for the M30 ultrasonic sensor, there is the possibility of having more sensors working together thanks to the synchronization function, and it is possible to ask for multiplex function models. Let's move now on the hybrid sensor, the UQ1, and I remember we just faced this topic during our first webinar. And as we said during that webinar, this is an hybrid sensor because it's a perfect fusion between a cubic ultrasonic sensor and a cylindric one, a cylindric M18 thread one. In this case, if we look at the classification in terms of sensing distance, it is quite similar to the one we saw for the UK6 series. In particular, we have UQ1A, UQ1C, UQ1D with the same ranges of the UK6 models. But on the other side, we have different kind of output for this series, because we have just mixed output, digital plus analog, and of course the models with IO-Link communication. What about the main features? For this series, we have just plastic body models with just plug-in M12, and we can, in this case, let's say, use all the advantages of having a hybrid sensor, because we have two kind of installation. On one side, the installation typical of a cylindric sensor with the M18 thread. On the other side, the installation typical of a cubic sensor with the frontal screws. Also, in this case, we have the teaching button, through which you can set the sensor as you want in order to get desired informations. Then we have to underline here that this is a very compact sensor, and thanks to its compact size, it is possible to install it everywhere even if the spaces are so limited, and that it represents an alternative from a mechanical point of view to cubic photosensor, to cubic photoelectric sensors, especially when talking about environments, dusty environments, and environment with the presence of transparent or shiny objects. Let's move on now to the cubic series, UH. In particular, these sensors work with through beam technique, so they are not diffuse, direct diffuse models, they are not retroreflective, they work as a barrier. It means that the two elements of receiver and emitter are physically separated, physically divided. It makes it possible to increase the speed, to increase the switching frequency, and it makes it possible to, let's say, delete the blind zone. In fact, as you can observe here, the two macro models, UHZ, UHS, do not have the blind zone. They work respectively at 300 millimeters and 1100 millimeters. They provide single output, single digital output, PNP or NPN, and mechanically they have a plastic compact housing, as you can observe in these pictures, with a cable connection. Finally, in our, let's say, portfolio of ultrasonic sensors, we have also this series, the FC8U, our ultrasonic forks, for particular application. In detail, the applications related to the detection of transparent labels, which could be very critical by using, let's say, photoelectric forks. In this case, we are able to detect very small labels in the order of 2 millimeters, and with a very small gap between two consecutive labels, also 2 millimeters. Mechanically, there is a metal housing, and it is possible through a button to make the manual adjustment and to switch between light on and dark on logic. Here too, as it is possible to see, there is a very high switching frequency, 100 and 1500 Hertz. Okay, let's move now to the final part of this lecture, the practical one. We want here to show you how to adjust a sensor, and we are going to do it in two ways. First of all, through the teaching button procedure, and then through the remote teaching. Let's start with the first one. In particular, here we are going to consider a double digital output sensor of UK1 series. And as you can observe here in the table, three possible detection modes can be selected. The first one is called the single point, because we are going to set just one single point for each output. Then we have the window mode, so a window with two extremes. Between that, we have the two outputs working with complementary logic. And finally, the 2 points or hysteresis mode, and we are going to observe now. So now we can see how does practically it work. Here we have, as I said, an UK1D sensor working with a double digital output. And of course, we have an ideal metal flat target in order to have the ideal situation. Now, Giovanni is entering the menu, the selection menu. How? By keeping touched the button for 8 seconds. Then we can move through the menu by selecting one of the 3 possibilities. In this case, we selected the first one, the single point one. So now for each, let's say, output, we can set the point. We have set the first point for the first output, then the second point for the second output, and you can observe how the outputs are activated or deactivated. In particular, while the green LED shows that the sensor is catching back some echoes, the orange one shows that the output, a specific output, is active or not. In this case, the first and second output are active. Now the first output is active, and now they are both not active. Okay, now we can enter again the menu by pushing for 8 seconds the teaching button, and then we can move by selecting the second option, the window mode. Now we are in the window mode, and we are going to set the 2 different points. First one has been set. Now the second one, the nearer with respect to the transducer. And now you can observe that by moving the target, the 2, let's say, outputs are activated or deactivated. And you can observe that they have a complementary behavior. In fact, when one output is active, the other one is deactivated, and vice versa. Now we are going to enter again the menu, always by pushing for 8 seconds the teaching button, and then we can select the last mode, the 2 points mode, or hysteresis mode. In particular, this let's say this mode is indicated for all of those applications in tanks where we have to control a pump in order to let's say make the level over the minimum point when we are below, or below the maximum point in order to avoid an overflow situation. Okay, now let's coming back to the presentation in order to see how to teach with via cable, so with remote teaching procedure. In particular, with a UK6 model, we have the teaching button, but we are using the cable. In particular, we use the white wire of the cable, and we just touch for a second with the wire, with the white wire, the positive pole, in order to teach, in order to, let's say, to set your point. And then we keep connected this white wire to the negative pole when using the sensor. Of course, this connection with the positive or negative pole depends on the fact that we are using a PNP model. If we use a NPN model, we have to, let's say, to think in the opposite way. So to teach by connecting this white wire to negative pole, and then to connect the same wire to the positive pole when using the sensor. Now we can see practically how does it work. Here you can observe that Giovanni has changed the sensor. Now we have a UK6 with digital output. Now Giovanni from the electrical cabinet is connecting the white wire to the positive pole in order to, let's say, to set the point. Now he's connecting this white wire to the negative pole in order to use the sensor. Please remember always to connect, once you have set your point, to connect the white wire to the other pole, because otherwise this white wire would act like an antenna, catching all the electrical noises of the environment and creating some interferences, some, let's say, disturbances to your sensor behavior. Okay, now we can come back to the presentation, just to go here and summarize what we have learned today, what we have discovered during this lecture. First of all, we went at the discovery of the secrets of the ultrasonic technology. Then we translated this know-how into practical applications that we already solved with our products. Then we started to explore our product range, so M18, UK1 and UK6, followed by M30 UT series. Then with the hybrid ultrasonic sensors of UK1 series, cubic sensors of UH, FC8 series of ultrasonic forks. And finally, we just observed how to adjust a sensor both with the teaching mode for UK1 and UT series and through remote adjustment via cable for UK6 sensor. Okay, unfortunately, we reached the end of this lecture, but of course, a lot of interesting things can be still said. So for more information, or just for providing us with useful feedback about this webinar, I invite you to write us at info@microdetectors.com, and please visit our website to discover what's going on, so microdetectors.com. And do not forget to subscribe to our YouTube channel and follow us on LinkedIn. So thank you for your attention and your time, and see you soon at the next webinar. Bye bye.
Bye. Thank you. Bye.